All right, beautiful people. Today we are at task number 2 from Web Application Security inside the Introduction to Cybersecurity module. Today we'll learn about web application, or we will read about web application security risks. Let's say that you want to buy an item from an online shop. There are certain functions that you would expect to be able to do on this application. Most straightforwardly, the online order might go as follows. Log in on the website, search for the product, add the product to the shopping cart, specify the shipment address, provide payment details. There are a few main categories of common attacks against web applications. Consider the following steps and related attacks. Log in at the website. The attacker can try to discover the password by trying many words. The attacker would use a long list of passwords with an automated tool to test them against their login page. Search for the product. The attacker can attempt to breach the system by adding specific characters and codes to the search term. The attacker's objective is for the target system to return data it should not or execute a program it should not. Provide payment details. The attacker would check if the payment details are sent in clear text or using weak encryption. Encryption refers to making the data unreadable without knowing the secret key or password. We cannot cover everything, but we will present a few formal categories from a WASP top 10. Don't worry if these techniques sound alien to you. TryHackMe walks you through each vulnerability. Identification and authentication failure. Identification refers to the ability to identify a user uniquely. In contrast, authentication refers to the ability to prove that the user is whom they claim to be. The online shop must confirm that user's identity and authenticate them before they can use the system. However, this step is prone to different types of weaknesses. Examples of weaknesses include allowing the attackers to use brute force, that is, try many passwords, usually using automated tools to find valid login credentials, allowing the user to choose a weak password. A weak password is usually easy to guess. Storing the user's password in plain text. If the attacker manages to read the file containing the passwords, we don't want them to be able to learn the password, distort passwords. And here you can see 3 users with clear text stored passwords. I like this one. I like Christine with Batman 2020. Broken access control. Access control ensures that each user can only access files, documents, images, etc. related to their role or work. For example, you don't want someone in the marketing department to access or read the finance department's documents. Example of vulnerabilities related to access control include failing to apply the principle of the least privilege and giving users more access permissions than they need. For example, an online customer should be able to view the prices of the items, but they should not be able to change them. Being able to view or modify someone else's account by using its unique identifier. For example, you don't want one bank client to be able to view the transactions of another client. Being able to browse pages that require authentication, log in as an unauthenticated user. For example, we cannot let anyone view the webmail before logging in. Injections. An injection attack refers to a vulnerability in a web application where the user can insert malicious code as part of their input. One cause of this vulnerability is the lack of proper validation and sanitization of the user input. Cryptographic failures. The category refers to the failure related to cryptography. Cryptography focuses on the processes of encryption and decryption of data. Encryption scrambles clear text into ciphers, which should be gibberish to anyone who does not have the secret key to decrypt it. In other words, encryption ensures that no one can read the data without knowing the secret key. Decryption converts the cipher text back into the original clear text with the secret key. Examples of cryptographic failures include sending sensitive data in clear text, for example, using HTTP instead of HTTPS. HTTP is the protocol used to access the web, while HTTPS is the secure version of HTTP. Others can read everything you send over HTTP, but not HTTPS. Relying on a weak cryptographic algorithm. One old cryptographic algorithm is to shift each letter by 1. For example, TryHackMe becomes, just shift one letter by 1. This cryptographic algorithm is trivial to break. Using default or weak keys for cryptographic functions, it won't be challenging to break the encryption that uses 1234 as a secret key. You're right. Don't worry if these techniques look challenging or sophisticated at first. TryHackMe has dedicated in-depth rooms to help you understand and experiment with the various attacks against web applications. Answer the questions below. You discovered that the login page allows an unlimited number of login attempts without trying to slow down the user or lock the account. What is the category of this security risk? Identification and authentication failure. You notice that the username and the password are sending clear text without encryption. What is the category of this security risk? Identification and authentication failures. Yes, we have storing the user password in plain text. If the attacker manages to read a file that contains the password, it's basically clear text. But here we can see that we read that usernames or passwords or information is encrypted. So for this question, we choose cryptographic failures. Amazing.